Let's take a look at question number 9 from the Secureum RACE number 0. So we have another contract snippet, and we are to look for vulnerabilities or for reasons why the snippet is vulnerable. As usual, the snippet contains a single contract, which is called test. It has a constant, a mapping, an address to balance mapping, and it has a contribute function, which is externally payable. So the first option says that integer overflows leading to wrapping make this snippet vulnerable. And the only place here where there is some sort of addition, multiplication, or whatever can actually make an integer wrap here is here when the message value that was sent to the contribute function, so the ether sent to the contribute function, is added to the current contributions balance of message sender. So assuming there's only this way to contribute, assuming there's only this single way for contributions to be increased, we can pretty much assume that this is not possible to ever overflow, because there's just not that much ether in existence for it to ever overflow a uint 256. That's just not gonna ever happen, basically. So even then, this can't really overflow realistically. And even if it somehow did, we still are using Solidity 0.8 here, which has the native protection against overflows. And with this protection in place and no unchecked block here, that just means that it's safe and that integer overflows are definitely not possible in the snippet we're seeing here. Next, we have B, overly permissive function visibility on contribute. So the contribute function is externally payable, and for anyone to be able to send it any balance to contribute, it needs to be at least public or external. If it were public, you would still be able to call it externally, so this doesn't really make sense that this is somehow a problem for it to be overly permissive in terms of function visibility. So this option just doesn't make any sense if you actually want people to be able to call this function and to contribute their value to this contract. So B as well is not correct. Then we have C, which says incorrect use of message sender. So the only place where message sender is used here is for the contributions mapping, to basically find which one of the contributions within the mapping belongs to the current caller of the contribute function. And that is a total legitimate use, I would say. That's the best way to determine who is currently contributing. Sure, we could allow others to contribute for other people to pass in the address that they're contributing for in the parameters, but that is not an objective problem with this contract, and therefore C is also not correct. Lastly, we have use of strict equality. So the strict equality, or a strict inequality, I guess. This use of strict equality may break the max fund raise constraint. So we have a constraint here, or an expectation, that the maximum funds that can be raised through contributions is 100 ether, which is here hard-coded within this private constant. And the problem is that currently this strict equality basically doesn't ensure that people cannot contribute more than this maximum value, because the last person contributing, so let's say the current balance is 99. So the next person who's contributing needs to contribute exactly 1 ether for this require value to next time revert, to prevent people from contributing more value. So definitely not a good solution. And in general, you should not use strict equalities or inequalities, because there's things possible where people can, for example, use self-destruct to inject value into your contract. With ERC20 tokens, you don't really have a chance to prevent injection of funds either way. So always expect that it might not be possible or to hit the exact maximum values that you're looking for, and it might be possible that the values changed from what you expect them to be and stuff like that. So it is always better to use greater than, smaller than, greater equal, smaller equal than. Always use these relative equalities basically to make sure that this can't go wrong. So in this specific case, it would have been better if this require would say that the balance needs to be smaller than the maximum funds to raise. But even this would still be a problem, because now if it is 99, the next person who contributes can basically contribute 2 ether, and it would still go through. So basically it would be possible to contribute more than 100 ether, but it will only be possible to do that once basically, and only after too much has already been contributed, only then this require would prevent it. So instead, this address balance should add the current message value before making this check, basically, to see how much would the balance be after the current contribution would be added. And only if with the current balance plus the newly added value is below the maximum, only then we allow the contribution to go through, basically. In that case, it should be smaller equal to, basically. So yeah, and that means that the strict equality here is indeed a problem, and that makes D correct. And that's that.